The production of high-strength engineering steel begins with iron ore extracted from large open-pit mines.
The intense heat inside the blast furnace separates iron from the raw ore, creating molten metal used to produce industrial-grade steel.
These solid steel billets will soon be transformed into long steel rods that form the starting material for manufacturing extremely strong steel cables. Before the billets can be shaped into long steel rods, they must first be reheated to
Each rolling stage gradually reduces the thickness of the steel, while increasing its length, transforming the billet into a long steel bar.
Controlled cooling stabilizes the internal structure of the steel rod before it can be further processed.
These large coils of steel rod will now be transported to specialized factories, where they will be transformed into extremely strong steel wires.
These steel rod coils will now enter a series of machines that gradually transform the thick metal rods into extremely strong steel wires.
The thick steel rod must be gradually unwound from the coil before it can be fed into the wire drawing machines. Cleaning the rod surface is necessary to ensure smooth drawing when the metal is pulled through the wire-forming dies.
The lubricated steel rod continues along the feeding line, where a series of tension control rollers. The next stage of production will pull the steel rod through hardened dies to transform the thick rod into thinner, high-strength steel wire. The first drawing stage begins the process of transforming the thick steel rod into thinner wire by forcing the metal through hardened precision dies.
Multiple drawing stages are required to gradually reduce the diameter of the steel until it reaches the precise size required for high-strength wire applications. The wire will now enter a more complex multi-stage drawing system, capable of reducing the diameter of the steel wire much further.
The multi-stage drawing machine is capable of transforming thick steel wire into much thinner, high-strength wire.
Passing the wire through multiple drawing dies allows manufacturers to achieve precise wire diameters while maintaining the strength of the steel.
Each additional drawing stage refines the diameter of the wire and improves the uniformity required for high-strength industrial cable production.
The thin steel wire travels along a set of tension control rollers that stabilize the movement of the metal before it reaches the wire collection system.
The newly formed steel wire will now be collected on large spools before undergoing additional processing stages.
Once the wire reaches the required diameter, it must be carefully wound onto large steel spools for storage and transport. The spooling system winds the continuous steel wire into organized coils so it can be easily transported and fed into later manufacturing stages.
These wire spools store large quantities of steel wire, which will later be used to form the strands that make up massive structural cables. These completed wire spools will now be transferred to the next manufacturing stage, where multiple wires are combined together to form stronger steel strands.
Before the wire can be used for large structural cables, it must be coated with zinc to protect the steel from corrosion.
Dipping the steel wire into molten zinc creates a protective coating that prevents rust and corrosion during long-term exposure to weather and moisture.
After leaving the drying chamber, the fully galvanized steel wire travels across another tension control unit consisting of several...
The galvanized steel wire is now ready to be combined with other wires to form the strong strands used in massive structural cable manufacturing. Individual steel wires must be twisted together into strands before they can later be combined to form large structural cables.
Twisting several wires together increases the strength and flexibility of the metal, allowing it to carry much greater loads.
Each strand contains several steel wires twisted together to create a strong, flexible component used later in the production of massive structural cables.
Several twisted strands are now combined together to begin forming the core of a large structural cable. The aligned steel strands enter the front section of the cable forming machine. where a set of steel distribution plates organizes the incoming.
Combining multiple strands together significantly increases the strength of the cable, allowing it to support extremely large structural loads.
Multiple layers of twisted strands are gradually added together to build the thickness and strength required for heavy structural cables. The cable core must now pass through a compaction process that tightens the strands together and prepares the cable for protective finishing layers. The compaction stage presses the individual strands together to create a stable cable structure with a consistent diameter.
Units. The thick steel cable core moves slowly forward into the first compaction roller assembly, where several large hardened steel Applying pressure from several roller stages ensures the cable becomes more compact and maintains a consistent diameter along its entire length.
After leaving the first compaction section, the cable moves across a series of polished guide rollers mounted on adjustable steel brackets that maintain the alignment.
Stabilizing the diameter of the cable is essential for ensuring the cable can later be wound onto massive storage drums and installed in large structural applications. Stabilizing the diameter of the cable is essential for ensuring the cable can later be wound onto massive storage drums and installed in large structural applications. The cable must now receive protective treatment to ensure durability and resistance against environmental conditions. After the cable structure is stabilized, it must be protected from corrosion and environmental damage before it can be used in large engineering projects.
Wrapping the cable with protective materials helps seal the strands and prevents moisture from reaching the steel inside the cable.
The protective coating and wrapping layers ensure the cable can withstand harsh environmental conditions when installed in large infrastructure projects. The final stage of production involves winding the long structural cable onto enormous storage drums before transport.
The cable enters the winding machine, where the enormous steel drum begins rotating slowly, powered by a large electric motor.
The guide system ensures the cable is wound in evenly spaced layers, preventing damage and allowing
Once the drum is filled with cable, the entire assembly must be lifted and transported to shipping areas where
These massive steel cables will eventually be installed in large engineering structures, such as suspension bridges,